Okay, today I'm explaining maximum height and range of projectiles. First, maximum height it is denoted by h. So suppose if a body projecting with the initial velocity u, and this is the trajectory of the body. So this angle theta is the angle made by this initial velocity vector with x-axis. Now this velocity vector u we can resolve into two components. One is u cos theta, second one is u cos sin theta. U cos theta acting along the x direction because this is horizontal component. U cos theta, and second one u sin theta acting which is along y direction. Now just at projection point I am resolving like this. So first one is it is parallel to the x direction. Suppose it is x axis and y axis. So it is ux and it is uy. Just at the projection point means time t is equal 0. So now the body moving along y direction against gravity. So the initial velocity ux remains constant and velocity along y direction uy gradually decreasing with respect to time. So because it is moving against the gravity direction. But at particular point, the velocity along y direction is 0. That point is called maximum height. So suppose at this point, uy is equal to 0. Therefore, the distance between, suppose I am taking this point A and B, the distance between A and B is called maximum height. It is denoted by h. Now, to calculate the maximum height h formula, I am writing the given data here. The initial velocity, which direction body is moving along y direction, velocity along y is equal to u sin theta here, and displacement along s direction, s is equal to h I am taking here, and final velocity vector at maximum height v is equal to 0 or vy is equal to 0 it is. Then I am using here v square minus u square is equal to s, but here acceleration a is equal to minus g. So therefore from v square minus u square is equal to 2as, then v is equal to 0 minus u is u sin theta whole square is equal to 2. A is equal to minus g. S is the h, which is maximum height. Then here minus minus cancel. So therefore after squaring this equation, u square sin square theta is equal to 2gh. Therefore maximum height of a projectile body h is equal to, it is u square sin square theta divided by 2g. This is the maximum height of a projectile body. But from diagram clearly here, velocity of the body is changing along y direction. Suppose say one more point I am taking. So after maximum height, this is another point. So at this point, same it is parallel to x direction. Along this direction, velocity along x direction is ux. But this is vy. Already velocity component along y 0 at maximum height, which means at point A. So that's why velocity changes as uy to vy, and angle between these two 90. So finally, with velocity v is the resultant of ux and vy. With this velocity v, the body landing on the ground level. So this is the maximum height formula. H is equal to u square sin square theta by 2z. Similarly, range of projectile. Range it is denoted by r. Range r is equal to, r is nothing but horizontal distance from point O to point x. Suppose this point is x, O to x is the horizontal distance. This horizontal distance is range of a projectile. Then r is equal to horizontal velocity u cos theta u cos theta into time taken by the body from point O to X. Time of ascent plus time of descent. The total time is a time of flight. The time of flight denoted by capital T. But we know time of flight T is equal to, what is time of flight? We know equation T is equal to 2u sin theta by z. Time of ascent u sin theta by z. Time of descent u sin theta by z. So therefore T is equal to, capital T is equal to time of ascent plus time of descent, which is equal to u sin theta by g plus u sin theta by z, which is equal to 2u sin theta by g. So in place of T I am taking, so 2u sin theta divided by g. So if substituting this time of flight in this above equation, then the range of projectile r is equal to u cos theta into time of flight is 2u sin theta divided by g is 1. 2u sin theta by g. Then range of projectile r is equal to, so here first u into u square, then remaining value I am rearranging like this, 2 sin theta cos theta divided by g. But numerator 2 sin theta cos theta is nothing but sin 2 theta. Therefore, range of projectile r is equal to, so 2 range of projectile r is equal to u square sin 2 theta divided by g. So this is range of projectile formula. In this equation, if theta is equal to 45, we are substituting. If theta is equal to 45 degrees, 45 degree, then substituting in this equation r is equal to u square sin 2 into 45 divided by g. So 2 into 45, 90. Therefore, range r is equal to, it is u square into sin 90 divided by g. So this is the maximum range of projectile, which is r max is equal to u square divided by g. This is the range of projectile, maximum range of the projectile. So till now we discussed two formulas here, important formulas. Maximum height of a projectile body, h is equal to u square sin square theta by 2z. And another one is range of projectile r is equal to u square sin 2 theta by g. So in this equation, if substituting theta is equal to 45 degree, how much we got here? That maximum range of projectile is equal to u square by g. And next, one more topic. The trajectory of a projectile body is a parabola. So now discussing how it is the parabola equation. But we know parabola equation y is equal to some ax plus bx square. So now I am showing the path of a projectile body or trajectory of a projectile body is a parabola. See this one. The same diagram once again I am drawing here. The body projecting same with initial velocity u, and it makes an angle theta along x direction. This is the trajectory. Trajectory is nothing but path of the body. It makes an angle theta along x direction. And if resolving this initial velocity u along x direction and y direction, along x and y, along x direction we know it is u cos theta, and along y direction it is u sin theta. After resolving these initial velocity vector u into two components or rectangular components of velocity vector. So already we discussed just now, at this point maximum height h, velocity of the body along y direction 0, but still along x direction is there. But here, and again I am resolving, see, at initial time taken, it means time t is equal to 0. It is parallel to x direction ux. This is parallel to y direction vy. And after maximum height, this is another point. It is ux and it is vy. So clearly from diagram, the velocity of body along y direction changing, but along x direction, the velocity of the body not changing. It means here conclusion is the projectile body acceleration along x direction is equal to 0 because there is no change in velocity, but along y direction, velocity changing. So that's why acceleration of the body ay is equal to minus z. Why here minus? Because body moving along opposite to the gravity direction. Then ay is equal to minus z. Now I am calculating here displacement of the projectile body along x direction and along y direction. From those two equations, we will get parabola equation. So first I am taking here displacement of the projectile body along x direction. Displacement along x direction. Right. So here S is equal to x I am taking, and velocity of projectile body along x direction is equal to here u cos theta, and acceleration along x direction is equal to 0. Now if substituting here these three values in S is equal to ut plus half at square equation, ut plus half at square, S is equal to x, velocity along x direction u cos theta into t plus half into acceleration along x direction 0 into t square. Into t square this one. So 0 into something 0, this term 0. Then displacement along x is equal to, it is u cos theta into time taken t. So therefore, from this equation, time t is equal to x divided by u cos theta. So this equation I am taking equation 1. Next, a similar way, displacement along y direction. Displacement along y direction. So similarly, I am writing here given data. Along y direction, this one. So which values we know here? S is equal to y, and velocity along y direction is equal to u sine theta, but acceleration a is equal to, we know it is minus g. Now these three values I am substituting in this same equation. S is equal to ut plus half into at square. S is equal to y, and velocity u is u sine theta. So u sine theta into time taken t minus half into acceleration a minus g into t square. But from equation 1 already we got a time t value. That t value substituting in this equation, then displacement y is equal to, it is u sine theta into t value x by u cos theta minus half into g x by u cos theta whole square. So then here u cancel, get cancelled. Then y is equal to sine by cos tan theta into x minus g by 2 into, after squaring this equation, x square by u square cos square theta. Therefore, y is equal to tan theta into x minus g divided by 2u square cos square theta into x square. Now these two values are constant. So suppose let tan theta is equal to a, and g by 2u square cos square theta is equal to b. So if substituting these two values here, y is equal to ax minus b into x square. So this is the final equation here. A and b are constant values. So then this is a inverse parabola equation. But the projectile body, the oblique projectile body is a inverse parabola. So we got here negative sign. Actually parabola equation y is equal to x plus bx square. So this minus due to the inverse parabola.